Hey guys, today we are looking at 5.2, which is all about solving systems using something called substitution. So we're going to just jump right into an example problem here in the context. We're trying to determine who's going to win this race. You decided you were having some fun in the backyard and you were going to race your dog. You know that you can run 3 meters per second. Let's go ahead and start highlighting some information. You can run 3 meters per second. Your dog can run 5 meters per second. You guys both start at the same place, so the same starting line, but as soon as you start taking off, the dog gets distracted, stops and smells some flowers for 4 seconds before he or she, I guess he, male dog, starts running. We're trying to figure out how far you're going to be able to get before your dog catches up to you. So like we talked about yesterday, again, that's going to mean our position is exactly the same after the same amount of time. So that intersection between where your dog catches up to you is going to be the solution to that system. So first things first, let's go ahead and write our equations for ourselves and our dog. So for us, we know that we can run 3 meters per second. Our dog can run 5 meters per second. We know that speed is our rate. So if x is our time, y would be our distance that we've run. Our equation for ourselves would be y equals 3x. Our equation for our dog would be y equals 5x. But we're missing a piece of information here that I have highlighted in blue. We forgot to take into account that 4-second head start that we have. Now, it'd be really easy to just add 4 seconds to the dog, like add 4 here to the dog, but the dog's not the one who's getting the head start, so it's not starting further away from the starting line. Actually, we are the ones who get the head start, so we would say, oh, hey, well, let's just add the 4 over there. But again, you have to be careful with these problems. This one's a little bit tricky because we have a 4-second head start. And in this case, my y value, which means my y-intercept, is going to be a starting position, a starting distance from where our dog is. So we have a 4-second head start, but not a 4-meter head start. What we have to figure out here is how far we would be able to run in that 4-second time window, which in this case, since we can run 3 meters per second, our head start is actually going to be a 12-meter head start. So we get to start 12 meters ahead of the dog before we're both actually moving forward at the same time. So we get that 12-meter head start, if you want to call it that, for my 2 equations. So my system, and this is how it's usually written. So this is how we usually would write a system of equations. We write it with this bracket over here. I don't think you really saw that yesterday, other than maybe I don't even think the worksheet you guys had for homework last night had the little brackets there. Usually that's how it's written, that bracket to the left of it, rather than just having 2 equations stacked over top of each other. That dictates that, hey, this is a system of equations. These 2 things are related to each other, so treat it that way. So now we have to figure out where they intersect, which would mean where my lines intersect if I graph them, my solution to the system. Now, I could go ahead and find some graph paper and be able to solve this equation, to solve this system graphically, like we did yesterday. If I graphed the 2 lines, whatever point they intersect on the graph would be where the dog would catch up to you. But I want to look at some other options here, because while this one is possible to be able to graph, I want to be able to do things algebraically without having to rely on graph paper. So we're going to use this method called substitution. And just like it sounds, we're going to be doing a substitution in our solving process, right? Just like if we were going to substitute a number in for a particular variable, I'm doing the same thing. And the substitution that's going to happen here is because we're a system, we know that x and y mean the same thing in my system, right? I know that x in both equations are the same. The y in the first equation is the same as the y in the second equation. So what I end up doing here is kind of manipulating my 2 equations to get them to just a single variable. So I know in my bottom equation, let's just say our bottom equation, we know in this equation, my y value equals 5x, right? Y equals 5x in that bottom equation. No one's going to argue that. That's the equation that we set up. We know that our y value is equal to 5x. So what I can do, if I know y equals 5x in the bottom equation, I know y also has to equal 5x in the bottom or the top equation. So those two things that I have written there, I have boxed in red, are equivalent to each other. They're equal to each other, which means I can make this substitution and everything is still okay. I'm not doing anything that's against the rules. I know those two things are still equal to each other, so it's not going to unbalance my equation. So what I'm going to do is replace that y value in my top equation with a 5x. When I do that, which I'm going to scroll down here and make some space. When I do that substitution, I end up with 5x equals 3x plus 12. And if you notice, now I have an equation that has a single variable. I'm totally happy solving those. As soon as I'm down to just a single variable, I can solve for x, no problem. We've been doing that since August. If I was going to solve this problem, I would get my x's together on the same side. 5x minus 3x is a 2x equals 12. And then again, 2x equals 12. I'm going to divide by 2 on both sides. X equals positive 6. Now I have an x value. I got my first step in the solution. But we know a solution to a system has to be an ordered pair. It has to be both x and y. So once I know this x value, I'm going to go back to one of my two original problems and substitute that 6 in there for x to be able to solve for my y value. Now I'm going to do that in my bottom equation, right? Y equals 5x was one of my original equations. So y equals 5 times 6, because we found out that my x value is 6, which tells me my y is 30. Look at that. I've got my x, I've got my y. My solution should be 6 comma 30. That's my solution to the system. Interpret the solution in the context of the problem. Well, in this case, I'm going to write this in yellow. After 6 seconds, the dog catches me 30 meters away. Or you can say after 6 seconds, both me and the dog would be 30 meters from the start. However you want to kind of phrase that. But again, when we're interpreting the solution, when we have an actual set of numbers for the solution, you want to make sure you include both of those values. So I wouldn't want you to say just after 6 seconds the dog catches up to me. I want you to tell me where we are. How far away is it after that 6 seconds that we're both the same distance away? So that's solve using substitution. It is a little bit weird and takes some getting used to, but I'm telling you, this is the solving method that most people prefer. I've got Algebra 2 students who will continue when we do much more complicated system solving problems. They will continue to use substitution as their preferred method. So let's go ahead and jump down into some more examples on the backside. Again, you're starting with two things that you know are equal to each other, and it really doesn't matter which way you consider this. I can say, all right, well, in my top equation, I know y equals 6x plus 14, so I'm just going to say, all right, well, I'm going to replace y in my bottom equation with 6x plus 14. I end up with 6x plus 14 equals 2x plus 2. I know those two things are equal to each other, so I can now go ahead and solve. I'm going to get my x's together on the same side, constants together on the other. So I end up with 4x on the left side, negative 12 on the right. That gives me, divide by positive 4, and I get negative 3 is my x value. Once you have that x value, you're going to go back to one of your two original equations to solve for y. It does not matter which one. You will get the same solution for either of them. At least you should be able to. If you get two different answers, that means that's probably wrong. Actually, no. If you get two different answers, it's definitely wrong. They should be the same in both equations. So I'll use the bottom equation just because it's a little bit simpler. We know that y equals 2x plus 2. So y should equal 2 times negative 3 plus 2. So that's a negative 6 plus 2. So we get y is negative 4. And again, my answer should always be an ordered pair, x, comma, y, negative 3, comma, negative 4. And that's my solution. We'll do some more. Again, this is all about repetition, getting used to it, seeing some complex ones, getting used to them. Okay, so again, my substitution step, I know in my top equation, y is equal to negative 6x. So in my bottom equation, I'm just going to replace that y value with negative 6x. So negative 6x equals negative 8x plus 6. So when I switch colors up here, when I add 8x on both sides to get my x's together, I get 2x equals 6. So I divide by 3 on both. Oopsie, previewing my answer there. I divide by 2 on both sides to get positive 3 for my solution for my x value. So now I'm going to go back to my original problem. I know y equals negative 6 times x. So that means y equals negative 6 times 3. So y equals negative 18. So that tells me for number 2, 3, comma, negative 18 would be my solution. Not so bad once you get used to it. Now I'm going to show you number 3, but again, I will preface it like I usually do with these problems. Sometimes the problems just aren't very nice. They're not clean, nice answers. It's going to happen sometimes. I apologize ahead of time for that going to be the case here. I know that to start with, I know that y equals negative 2/3 x plus 11. So if I replace this y value down there with negative 2x plus 11, I can go ahead and solve. So that's negative 2/3 x plus 11 equals 7/3 x plus 8. So I'm going to go ahead and add 2/3 x on both sides, and I'm going to subtract 8 from both sides to move that away from there. X's will be together on the right. 11 minus 8 is 3. 7/3 plus 2/3 would be 9/3, which 9/3 x, that's really the same thing as saying 3x. Right, because 9 over 3 is 3. So I divide by 3 on both sides, and I get positive 1 for my x value. So from here, I'm going to take that x value, plug it back into one of my original 2 equations. It is up to you where you want to plug that into. I usually like just dealing with nice positives, so since they're both kind of ugly with fractions, I'm going to choose the bottom one here. I'm going to say that, alright, so if y equals 7/3 x plus 8, that means y equals 7/3 times 1 plus 8, which is 7 over 3 plus 8, which, let's see, 8, if I changed it into thirds, right, 8 over 1 times 3 on top and bottom would be 24 over 3. So in total, I end up with a y value of 31/3. Ugh, not pretty at all. So 31 over 3. You want to put it as a nice improper fraction. We can do it as a decimal, 10.3 repeated. It's up to you on how you want to do that one. Super ugly answer, but again, the same process. I'm starting with taking what I know one of my variables is equal to in my first equation, substituting that variable in my second equation to get a problem or an equation that has a single variable in it. That's the whole point of the problem. The whole point of substitution is you're trying to substitute so it's just a single variable. All right, last problem here in our notes, and this is just an example problem. This one, again, is going to be important for us because we're asked to interpret what the solution represents in the context of the problem. The solution itself, to be able to find it, same idea. I know what y is equal to in one of my equations, So I'm going to just substitute that in my other equation. I know that y is equal to 7x minus 8. So 7x minus 8 has to equal 4x plus 7. So I'm going to subtract, oops, I'm again previewing already, minus 4x on both sides to get my x's together. I'm going to add 8 on both sides to get my constants together. I apologize if I'm going too quickly for you. As always, you guys know you can back up the video, you can slow me down. If you open it up on the actual YouTube app, maybe in the settings in an embedded video, you can slow me down to half speed or quarter speed or 3/4 speed so you can, follow along, or feel free to pause. You guys know, you have control over me right now. You can make me, and then hit play. So, divided by 3, x equals positive 5. And then you go to one of your two equations. Doesn't really matter which one. I'm already on the right side here, so I'm just going to plug it in here. Y equals 4 times 5 plus 7. So y equals 20 plus 7. So y equals 27. So my solution is 5, 27. It should probably be helpful to talk about what the context is in this case, since we have to interpret the solution in the context of the problem. So we're having a water balloon fight between yourself and your friend. The rate at which you and your friend fill up the water balloons per minute is described as the following. So our equation was y equals 7x minus 8. Our friend was y equals 4x plus 7. So in this case, looking at kind of how the things are set up, your x would be your time, right? How many minutes you're filling up water balloons. Your y value would be how many water balloons you have. So in this case, if I was interpreting my solution in the context of the problem, I would say after 5 minutes, both have 27 water balloons. And that would be it. That would be my interpretation in the context of the problem. What does the solution represent? Right, it's the time. It's how many balloons we would both have, so that or maybe you would say how long you have to fill the water balloons up, so that you both have the same number of them. However you want to say it. All right, that is all for today. That is everything for 5.2. That is everything for solving using substitution. Again, this process, if it's confusing to you at first, give it some time, give it some practice. I know it's not necessarily the most intuitive, but give it some time and it'll sink in. I'm telling you, this is the method that most people gravitate toward because it's pretty straightforward. You take something that you know in one equation, plug it in the other one. We're used to that substitution step, so some of the other the other solving methods can be a little bit more abstract. So give it some time. Your homework for tonight is page 245, 4 through 18, just the evens. If you have any questions, concerns, thoughts, ideas, hopes, or dreams, as always, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.